So now we're ready for the last part of section 6.2. The last part of section 6.2 talks about inverse functions. And to give you an idea of what is happening here, I've started off with a picture that we've seen previously in, again, section 3.1. So we have a function f sitting here, and a is getting mapped over to b. A is in the domain of f, and b is in the range of f. So what we have then is a function f, and what we want to create is a function that undoes what f does. So if f maps a over to b, we would like to create this new function that takes this and goes the other direction, and maps b back over to a. So the first comment about this is that this kind of new function will only exist if f, the original function, was 1-to-1. And that's why we needed to have that definition from before. So once again, this new function will only exist if f was 1-to-1 in the first place. So now that we have this idea that we want to undo this function f, let's go ahead and give this new function a name. Now, I could just choose another letter, but I want to make a comment about the fact that it's the function that undoes f. So the first thing I'm going to do is write down the notation. The notation is f with a superscript of -1. Now, you have to be kind of careful on this one, because sometimes people look at this and they say, that's a power of -1. That's not true. This is not an exponent. It's simply a superscript. So it's f with a superscript of -1. So now that we know what the notation looks like, how do we read that? This is called f inverse. So f inverse is the function that undoes what f does. So now that we know that this f inverse exists, we can talk about a lot of different things about this f inverse function. So first off, let's talk about it in terms of the words of domain and range. Well, as you look at f inverse, the arrow for f inverse starts on the right. So that means then that this is going to be the domain of this new function, f inverse. And the arrow for f inverse ends over on the left. So that means this is going to be the range of f inverse. So as you look at this picture then, there's something interesting to note. The domain of f and the range of f inverse are in fact the same set. And the range of f and the domain of f inverse, once again, are the same set. So that's something to keep in mind for the rest of this section. The other thing that we can do with this is come in and think about functional notation. So I'm going to go ahead and say then that originally I had an arrow for f, and f mapped a over to b. Well, functional notation says write down the name of the function, write down the input value, a, and that's going to equal the output value of b. But now that I know that we can have this new function called f inverse, I can also write down some functional notation statements for f inverse as well. Well, f inverse is going to have an input value of b. So there we have that. And that maps over to a. So f inverse of b is equal to a. So now that we have those two pieces then, you want to think about what that means in terms of a graph. So if f of a is equal to b, that means that on the graph of f, we're going to have the point a comma b, because we have the x-coordinate and then the y-coordinate. But on the graph of f inverse, we're going to have the point b comma a. So on your handout, you're going to notice that I've given you a box. If the point a comma b is on the graph of the function f, then the point, fill in the blank, is on the graph of f inverse. We just found that it has to be the point b comma a.